Hello, everyone. My name is Scott Grizzard from University of South Florida. This is Calculus Fall 2020, and we're going over quiz 10B. So this quiz is about mean value theorem, Rolle's theorem, things like that. So let's go ahead and get started. There we go. Okay, so I want to state the mean value theorem. So I don't remember all the details of the mean value theorem all the time, right? I have a picture. So here's my picture. I have this picture that looks like this. Oops. All right, I've got kind of this picture where I do something like this. Oops, let's actually have f be a function. And I've got some b, I've got some a. This function could continue. I don't know if it does or not. Blah, blah, blah. But I've got some b and I've got some a. And I've got an f of a, and I've got an f of b. And then I've got this secant line going from there to there. Come here, ruler. D. Right. And the secant line, this is s of x, s, a, b of x, whatever. But that means that there's some place. Stop that. Right. So this is a 40-degree line here. And there's some place where I have a tangent line. Come here. Stop doing that. There's some place here where I have a tangent line, where the line tangent has the same slope. So the line, there's some u, so that the slope, right, so that f prime of, this is not going very well. It goes. Imagine that's a very hard computing problem to solve. Equals MAB. Right, so how do we feel about this? This would be the secant line, AB, whatever. How do we feel about this drawing 1 to 5? Kind of what I want to do here. So the drawing. 1, 2, 3, 4, 5. So how do we feel about the drawing 1 to 5 there? It's just how I remember it, okay? All right. So what I do here, now that I'm going to state the theorem, I'm back. There we go. Well, too much. So now I want to state the mean value theorem. Okay, well, let f defined on AB if f is continuous on the close and f is differentiable on the open, then there exists u in a b so that f prime of u equals m a b. And then I'll put m a b equals f of a minus f of b over a minus b. Or I could say m a b equals f of b minus f of a over b minus a, because that's the exact same statement. Okay? So how do we feel about this 1 to 5? And the stuff that's required is the stuff I put in dark purple, by the way. So statement of MVT. Okay. All right. Okay. Yes, so the dark purple's the required stuff. Okay. All right. So do you believe Marvin the Martian? Marvin the Martian says this function has more than one root. Do you agree or disagree? If you agree, prove the statement. If you disagree, prove the statement is false. Okay, so Marvin the Martian says that f of x equals 2x plus cosine of x has more than one root, more than one real root. All right, so if I have time, and I'm faced with this kind of question, and if I have time, I'm going to actually make a quick sketch. Okay, so I'm going to just grab my calculator, and I'm going to do a quick sketch. And your calculator, even the ones that you, even a calculator that has a, some of those nicer calculators, even though they're not graphing calculators, a bunch of those scientific calculators that are legal will actually make a table of values for you. You put in a chart, you put in a function, and you put in some x values, and it tells you the y values without having to enter the function a bunch of times. So if you don't know how to use that if you don't know how to use your calculator to do that, I would advise you learning how to use your calculator to do that, because it will save you a ton of time. Okay, so learn how to make your calculator do the table. Okay, and if you don't have one that will do it, get on that list of legal calculators. I think it's the Casios. A bunch of those will do it. So if you don't have a calculator that will do this, you have one of the the TIs that are kind of wussy. Spend $10. And you don't have to, but for functions like this, it will save you a bunch of time to not have to enter in what x is a bunch of times. Okay, does that make sense? So how do we feel about what I'm talking about? So how do you feel about calculator makes table? So let's see. I want to end that poll, and I want to start that one. So how do we feel 1 to 5 about this idea that I can get a calculator that makes a table for me? Okay, and I'm just going to throw in some quick values, right? So if I have 0, right? So if x is 0, I'm going to wind up with with 2x plus cosine of x. That's going to be about exactly 1. Then if I have x is -1, I'm going to wind up with like negative 1 point, I think it's like 4.6-ish, right? 1 is if I throw in 1 on this thing, I'm going to have like 2.54-ish. Right, so what I do is I just throw in a bunch of stuff here. And maybe I'll do the 2's. But the point is that I look at this function and I say, wait a minute, right? If I go to -2, I'm going to wind up at negative 4-ish. And if I do +2, I'm going to wind up at like -3.5. The +2 would be 3.5-ish. So what I do is I kind of just make myself a little table of values, and I look at this, and I got something that's going to look a bit like, the point is here that, this 2x kind of dominates the statement. Okay, so after I do, right, I didn't actually have to graph it. I just needed a few points. And the idea here is I get this idea that the 2x just kind of dominates and it's only going to cross once. Right, because if I was going to cross twice, it'd be somewhere in this kind of 0, 1 type area. Okay. So I think Daffy is wrong. Or Marvin is wrong. So I'm going to say I disagree. Marvin is wrong. And it's important to note that this is not a proof, right? But this will give me some points. I said I disagree, and I have kind of a sketch, right? So it's not a proof, but if I was running out of time or something like that, or I didn't know how to do it, you know, I have a sketch. So what I'm going to do is I'm going to say this function only has one. So what I'm going to say is this function only has one real root. There is only one x so that f of x equals 0. Okay? Proof. Assume otherwise. Yeah. Then there are two x values, a and b, so that f of a equals 0 and f of b equals 0. Then I'm going to say, since 2x and cosine of x are differentiable everywhere, so is f of x, which equals 2x plus cosine of x. And if I want to be extra very special, I say that's the sum law. I don't have to say that. By the sum rule. That's one of the things, right? If two functions are, that's part of the sum rule. The statement of the sum rule says, if two functions, if f and g are both differentiable at x, then f plus g is differentiable at x and the derivative is. So that's part of the statement for the sum rule, but you don't have to say that. It's just enough to say that alone. Okay. In particular then, that means f is continuous on a b and differentiable on the open. Since f of a equals f of b by Rolle's theorem, there exists u in a b so that f prime of u equals 0. But f prime of x equals 2 plus sine of x. I'm sorry, 2 minus sine of x, which is bounded by 2 minus 1 and 2 plus 1, or 2 minus minus 1. So f prime of x is never 0, implying f prime of u does not equal 0. This is absurd. F prime of u cannot be both 0 and not 0. So no such f. Not no such f exists. So f may have at most one root, or there's at most x or one x where f of x equals 0, etc., etc. Okay, so how do we feel about this 1 to 5? And it's a long one, and I know that. And I've said a little bit more detail, but the whole problem. Okay, so I've got some 1s and I've got some 3s and I've got, I don't have a lot of 5s. So what I'm going to do then is I'm going to pause and I'm going to talk about this for a little bit. And then what I'm going to do is short shrift number 3. And then at 5 p.m. I'll go into detail on number 3 and short shrift number 2. Okay. So let's talk about this thoroughly, and please ask questions in the thing while we're going through it. Okay. So here, what I've done, I've got a little bit more. But what's the big idea? The big idea for this type of thing was the following, was that f prime of x equals 2x plus 2 plus sine, minus sine of x. And this right here is always greater than 0. Right? Because sine because whatever sine is, sine of x is always bounded between -1 and 1. So it's kind of like those original you remember those, like, what do you call it? The 2 cops problems, right? I had a little bit too much coffee today, so I'm like, I'm all jittery. You remember those 2 cops problems where you kind of had something that was bound, you had this kind of x squared sine of x deal, and you used the fact that -1 was always less than sine of x, and 1 was always greater than sine of x, and then you multiplied through by x squared, and you were careful with the inequality. It's sort of like that. That's the big idea, is that sine of x is stuck between these 2 values. Okay, so how do we kind of feel, how do we feel about that? Let's see. So this is this idea that sine of x is trapped. So f prime of x is stuck. Okay. There's not a lot of voting going on here. Please vote, especially if you're feeling bad about it. Okay. So, right, if I take the graph of sine of x, right, here's the, let me turn off this cosine thing. So here's the graph of sine of x, and it's just kind of always stuck there. Oops, nope. All right, so here's the graph of sine of x. Okay, so that when I take the derivative here, I'm going to get 2 minus sine of x. Right, and 2 minus sine of x is never 0. Right, it's always above the axis. And that's the kind of thing that's going to lead me to a contradiction. Now, I can use mean value theorem here instead of Rolle's theorem, by the way. So if you wanted to do a mean value theorem version of this, if you only wanted to memorize one theorem, you just use the fact, you insert right here. So if I wanted to use MVT, this is 0 minus 0 over a minus b equals 0. Okay, so I can use MVT instead of Rolle's theorem if you just want to remember one of them. Okay. In one sense, the mean value theorem is just a generalization of Rolle's theorem. Okay. So, how do we feel about this, this kind of thing now? So let's ask this question again. How do we feel about the sign trap now? Okay. All right. So I want to use, so this is going to generate my contradiction. So if I want to use Rolle's theorem, going back, since I want to use Rolle's theorem, I need to show the following. Show f is continuous on AB, f is differentiable on AB, and f of A equals f of B. So kind of what I'm doing here is, okay, and the way I show this, these other two conditions are trivial to show in the sense that I just have two differentiable functions adding together. So but I need to mention, you need to mention that this is true. I need to mention that this is true. And then I just have some details, right? these are like details. I could have just said, you know, if I didn't have details, so this is absolutely essential, and this is essential. These are details, and then I just kind of invoke Rolle's theorem. Okay, so no one's asking questions. People are wanting me, but or toing me, but not asking questions. What are your questions about this? Okay, someone write what they think is the process to immediately recognize that this is an MVT or Rolle's theorem problem. Okay, so someone's asking, and the don't feel stupid. This stuff is hard. So someone's asking in Twitch, can I elaborate on what's being asked? How you figure out what's being asked. So what's being asked? Okay, so what's being asked here? What's being asked is that. So Marvin is saying, so clarification. So what's being asked? Let's do this. Marvin is saying, Marvin is saying the following. Marvin is saying that F saying that there is more than one place where f of x equals 0. Okay? There's more than one x value where f of x equals 0. Okay? So how do we feel about that's what he is asserting? 1 to 5. Okay. So the intuition here, okay, so that's what he's saying. So the opposite of that, what would it mean for that not to be true? Right? If it's not true, then there is at least 2 such places. Okay? Right. I didn't assert that there was... Right? There could be no real roots. I didn't assert that there wasn't. Now, immediately from the intermediate value theorem, right? Since this is a continuous function, you know that it has at least 1 because 0 gave you 1, but -1 gave you something on the other side of 0, right? So by MVT, we know that there's at least 1. But what he's saying, so I'll just put that by MVT, I'm sorry, by IVT, not MVT, by the intermediate value theorem, we know there is at least 1. Okay, that's kind of an aside. Right. But the idea is that if this is not true, then there would be at least 2 such places. So I'm just going to call them A and B. It's not that f of x would not have to be a function. It is a function. It's that, but it's a special type of function. It's differentiable everywhere. Well, so if his statement, so what Marvin said is that it has no more than one real root. The opposite of that statement is that it has more than one, right? So if this was not true, there would be more than one. In other words, there would be at least two. Right? There's at least two. And I don't know what they are. I don't care what they are. And that's sort of the point. I don't actually need to know where the root is. I know that it's somewhere between 0 and -1, but I don't need to know what it is. So I'm just saying, suppose otherwise. But that means there's at least two. I don't know what they are. But it would be true that there would be at least two. So how comfortable are we with this idea that I don't actually need to know what the roots are? So, and that's kind of a weird thing, especially for a mind that's geared towards science, right? But science, you actually want to know. You're like, I want to know what they are. I want to know what they are, right? That if your brain is used to science, this makes you uncomfortable. Okay? Because this is like, well, wait a minute. So a root occurs, so a stationary point is when f prime of x equals 0, or that if f prime of x equals 0, you have a stationary point for f, and you have a root for f prime. Okay? A root is where f of x equals 0. Okay, it's the x so that f of x equals 0. Okay. Okay, so 1 to 5 on the entire proof now. Okay. So we need this definition. In order to do this problem, there's a bunch of pieces you need, right? You need the definition of what it means. So what's the thing saying, right? The definition of a root is needed here. Marvin is saying that there's more than one place where f of x equals 0. And so I'm just going to say, okay, suppose there are two. Call them A and B. I don't know anything else about them. I just know that f of A equals 0 and f of B equals 0. And then I apply Rolle's theorem to say that there's a place where f prime must equal 0. Of course, f prime is always greater than 0, and that's our contradiction. Okay. All right. There's still a bunch of people that are threeing me, and there's a person that's giving me a 2. That's okay. Let's talk about this some more. Come to office hours or make an appointment. Let's talk about this because I really want you to get that. This is hard. And it's complicated, right? There's a lot of moving parts to this. So if you haven't chunked the idea of a root yet, and you haven't chunked the idea of Rolle's theorem yet, it's going to be, and if you're still trying to chunk this idea of the derivative, that's going to be hard because there's complicated because now there's multiple points that you kind of have to chunk together in your brain before you can get to the point where it's simple. It's still hard, but now it would be simple but hard instead of complicated and hard. So you need to chunk the following ideas. Right? Roots are where x is f of x equals 0. And you need this idea of Rolle's theorem. And a couple of others. So you need some chunking. Yes, somebody has a question. Office hours, by the way, are 12:30. Right after this class, Monday and Wednesday, and then Friday has on campus. Okay. Person raised their hand and didn't mean to. That's okay. No problem. Okay. So as I was saying, there's a lot in here that has to be chunked. And you need this idea of, kind of the slope thing, the flat slope thing needs to be chunked. Okay. All right, let's move on real fast. As I said, I'm not going to spend a lot of time on this problem. I'll spend a lot of time on this problem on the 5 p.m. But let's just do this. So, if so, give an example of a function. Well, let's see. The first thing I do when I see this is, okay, f of 0 equals 0, f of 10 equals 10. I've got a continuous and differentiable function, and I know that the function always has to be above this line or below this line. So I'm going to try, let's see, can I make this happen? So, nope, I can't there because I've got to go up. I can't there. Right, so if I've got a function that goes up like this and then down, there's going to be some place where I wind up with a tangent line of 1. So I look at this and I go, okay, m a b equals f of 10 minus f of 0 over over 10 minus 0, right, which equals 10 minus 0 over 10 minus 0, which equals 1. Okay. So I say no such function can exist. Reason MVET. Okay, so I kind of just had my strategy and all things rolled into one. And then I'm going to say proof. Okay. Well, suppose that such a function did exist. Okay, so MAB equals, and then I'm just going to say 1 because I already set it up here. Okay. Since f is continuous, is differentiable everywhere, f of, f is continuous on the closed. Right. I could just say AB there because I already said what A and B were. But I do need to say what A and B are if I'm going to say that. So by the mean value theorem, there exists u in 0, 10 so that f prime of u equals MAB, which equaled 1. However, f prime of x does not equal 1 anywhere. So f prime of u does not equal 1. This is a contradiction. So such an f cannot exist. Okay, how do we feel about that one there, 1 to 5? So this is the question 3. It's question 3, right? All right. Okay. All right, so that's the quiz. Do I mean to say f prime of u does equal 1? Well, I mean to say here that f prime of u does not equal 1, but f prime of u does equal 1, and that's a contradiction. All right, so this should be not equal, and that should be equal. Right? I can't have both, right? I can't have f prime. This is a contradiction. F prime of u not equal 1 and f prime of u equals 1 cannot both be true. If you wanted to clarify that. Okay? So such an f cannot exist. Okay. So let's that's it for the quiz. Let's talk about the problem set.